All right. Thank you very much for being here at the Let's Talk. I know that some people might have expected the charging station security talk, but sadly that was canceled. So instead, my talk was kind of pushed a little bit forward. A couple of minutes ago, I was doing some pictures with the robot. Did anyone manage to root the robot already or hack it? I mean, the Wi-Fi should be still open. I know some people tried. Anyone successful? No? Sad. Okay. Before we start, I'm kind of curious. So who of you has IoT devices at home? Maybe with a show of hands. Anyone has vacuum robots? Okay. Did anyone already do IoT hacking before? Okay, that's a few. Okay, interesting. Perfect. This talk might be very good for you. I added a lot of beginners notes. So yeah. So some information about me. I'm a security researcher, or some people call me also a hardware hacker. Let me turn my robot off real quick. Because I think people start to hack it now. So my research field is wireless and embedded security and privacy, and I did most of my research at Northeastern University in Boston in the US. I also enjoy teaching and sharing knowledge, so part of my kind of enjoyment of sharing knowledge is giving this kind of talks, but I'm teaching also classes like software vulnerabilities or network security. So I do quite a lot of things. Because due to the amount of how many vacuum robots I have, I call myself nowadays a vacuum robot collector. So I have for the last 5 years every robot which came out basically on the market. And my main interests are the reverse engineering of interesting devices. This can be literally anything, but my current kind of objective is vacuum robots, obviously, smart speakers, and flash memory. Okay, so let me talk real quick about some of my projects, which might be also some inspiration for you guys. So a while ago, I was doing a paper about Amazon Echo Dots. Basically, I was buying something like 85, 86 used Echo Dots on eBay. Got them, disassembled them, read out the flash, and tried to kind of figure out, okay, how much private data is still on them. And let's say the paper kind of revealed that there was still a lot of data, and I was able to reconnect the devices back to the user account of the user, and was potentially able to do some shopping or get the Wi-Fi credentials. So this was very, very bad news for Amazon. Interestingly, this was also the beginning of some research which I was doing with Amazon Sidewalk, because Amazon, thankfully, they left the debug firmware for the Sidewalk protocol in one of the firmwares, and including with all the debug symbols. So this was very great, and kind of shows that if you read out flash memory, it's always a good time. The more broad kind of field what I do is flash forensics. So I analyze the flash of embedded devices and try to find if there's anything interesting or deleted data or any other things. But also I look at flash memory itself. What most people don't know is that a lot of flash memories have an embedded controller onto them, which has its own firmware, and I try to find ways to kind of manipulate the firmware and do some sketchy things, for example, to bypass secure boot or trust zone. On the left, you see one of the pictures is a Pixel watch, which is assembled where I remove the flash and try to kind of probe a couple things. Another project which I spent a lot of time surprisingly in is robotinfo.dev. So I have, as you see in the picture, I have a huge collection of vacuum robots. This is one of my shelves. I have a couple of them. So I have something nowadays 50 vacuum robots and a couple of lawnmowers, which are smart. And what I do is a systematic analysis. I disassemble the robots, I figure out what kind of operation system they have, which sensors and vulnerabilities, and put them in the database. And this database basically has a focus on security and privacy. What I use it also for is tracking firmware changes, because in the past I learned that you can discover a lot of new routing vulnerabilities by just looking at firmware changes, by just seeing okay, what do they change? Did they know anything which we didn't know? And in the past I had a DEF CON talk where we basically knew that there's a new way to root a device by looking at firmware changes. The source for that database is basically emulated devices and the app. I will later explain how it exactly works. But this is basically the base for my research. So, what is the goal of this talk? Well, I would like to explain what motivates me to do that, and what also makes IoT devices so special. Also, I will talk briefly how you can reverse engineer the XIAOMI ecosystem as an example, and why you should start with IoT hacking, because this is a field where there might be a lot of undiscovered potential for you to start, and this might be a difference between getting a cool job or just having boring job, basically. As a side note, I'm not talking about smartphones. Smartphones is in my definition, at least not really IoT devices. And also gaming scopes are, game consoles are out of the scope of this talk. All right. So the agenda for this talk today is we start with the motivation. I will give you an overview of the IoT devices from a perspective from a hardware hacker like me. When we talk about the XIAOMI ecosystem, I will explain to you how I reverse engineered the ecosystem, some of the findings, I mean not all of them, but some of them, the most interesting ones, and then we will have the summary. So let's talk about the motivation. Why do we want to hack IoT devices? Well, from my perspective is I want to play with cool hardware because these devices are kind of powerful. They, are fairly cheap if compared to if you buy the sensors on their own. On the other side, for me, as someone from Germany, we are a little bit paranoid of devices calling home and sending data. And so I want to prevent the devices from, uploading data to China, uploading data to the US. I mean, US is maybe also very snoopy. So we want to just cut that off and just use the device as is. Another thing which is very, very popular, and especially in Europe, is that people use IoT devices with their custom smart home system. For example, Home Assistant, FIEM, there's a couple random systems where people can automate more things in their home by just disconnecting from the cloud and not be dependent on a particular cloud vendor. A thing which is important for my research is actually I want to verify the privacy claims which vendors do. A lot of vendors claim, hey, we have certifications, we never upload your data to any place, it only stays in Europe, it only stays in America. We would never make pictures of you, we would never record you, we would never upload that to the cloud. The question is how do we verify that? There's some certifications, but the question is how valuable are the certifications at all? And of course, and I think many of you are here for that, well, we want to make big bucks with bug bounty programs. And surprisingly, IoT devices might be a good way to do that. So, the other question is why don't we trust IoT and in extension the IoT companies? Well, the problem of IoT devices is that they are connected to your home network, so they have typically access to everything which is in your home. Most of the people just put them in the same Wi-Fi as all the other devices. I know the typical recommendation is do you have to separate Wi-Fi for IoT devices, but it's very realistic, not many people do that, so maybe including me. So the other thing is the vacuum robots have a lot of sensors. I will show some examples later, which might collect data which you don't want to be uploaded to the internet. One of the tricky things is all the communication which is going to the cloud is typically encrypted, so you don't have any idea what's in there. If they upload pictures, if they upload voice streams, if they upload just log files or some whatever telemetry data, you have no idea because it's an encrypted TLS stream. There was a talk 15 minutes ago, which was talking about how you can try to break into that SSL thing, but let's assume that it's secure, so you have no idea what to do there. A lot of devices which I analyzed were creating something like between 200, 300, 400 megabytes of data every month just uploading to the cloud, and you have no idea what they do. One thing which is kind of important to know is that developing secure hardware and software is very hard. So even if we talk about non-malicious vendors, they might get hacked, and people might figure out vulnerabilities in the devices and use them to, impact a huge amount of people. And one of my favorite things is that vendor claims contradict each other. So, as mentioned before, a lot of them are kind of claiming things which, are a little bit weird. I have an example for that later. So, and one of the things, certifications are worthless. There are two German companies which do a lot of certifications for IoT devices, which is TÜV Süd and TÜV Nord, I think. TÜV Rheinland, sorry. And in my experience, always the devices which have certifications for IT security are the ones which are the most insecure ones. At least I got root access to any device which had a certificate, so this was kind of interesting. So let's talk about an example which I usually use on every talk which I have, and this is a talk. This is an example from Roborock. A couple of years ago, we were claiming hey, this device with a camera, this vacuum robot, it will never make any pictures of you. It will never upload the data to the cloud. All the data is only stored and not stored at all, but used for AI detection of objects. So please trust us. Everything is fine. We are certified. Nothing is sketchy. The camera can be accessed remotely. But if you scroll down on the same page, you will have this ad hey, by the way, you can access the camera remotely, so to watch your pets at home. It's super easy. You can drive around and you can hunt your cat down. And now the question is like, hey, okay, wait, you said like one page above, like, oh, none of the camera data is ever sent to the cloud, but I can't access the camera data remotely from my phone. So it's a little bit like, it's a problem, right? So it's a contradiction. The other thing is, even if we're not talking about Chinese companies, even US companies get caught from time to time, but they do shady things. In this particular example, I was working with the journalist. People figured out that iRobot was making pictures of users. They were basically development devices, and they were doing pictures, and then they were giving them to Venezuelan gig workers to label them for AI usage. And this was a kind of big scandal, which was a couple months ago. And here are some examples. Basically, this is like a kitchen. On the right is a kitchen. On the left, you see like some labeling of the gig workers. The question is, why do my vacuum robot needs to know what kind of wall switches I have, or whether I have a fan on the ceiling? So this is kind of like things which are kind of a little bit scary. And this is an American company, by the way, so all the companies do sketchy things. So this is one of the reasons why I'm very interested in that. The interesting fact is, as soon as this research for this article started to go, and she was sending out emails to everyone, all the vendors started to change their firmware and change their privacy policies, because everyone was panicking, like, oh, dang, we can't get caught. So everyone was like panicking, and we saw a lot of like changes in the firmware, which was kind of like not uploading things that often anymore, but we still had the old cases. Another thing, these devices get more and more sensors, and a couple of years ago I was kind of making jokes like, hey, can we use like some ultrasonic sensor from a vacuum robot to snoop on people, to kind of listen, like use them as a microphone. The problem is nowadays they don't only have cameras, but they also get microphones. So this is like a example from Ecovacs, which is not in Xiaomi ecosystem, but just an example, which nowadays has microphones which you can potentially access if you root the device. And so you don't need to find a way for like a weird sensor to kind of use it as a microphone. They come with microphones nowadays, overly built in, so which makes it a little bit more scary. And speaking of which, what I mentioned before, certifications are kind of worthless nowadays. So most of the devices I hacked basically, and was giving talks and published like routing methods for people, had certifications from the TÜV, which were in compliance with the European cybersecurity standards. We said like, yeah, no data is like stored, everything is fine, but basically we were proving it otherwise, which kind of told me, okay, whatever the companies are doing for certifications, it's basically, bogus, or I never figured out exactly what the actual checklist is, but it basically shows that they're kind of useless. Okay, so in the next thing, let's talk about the IoT devices from a perspective as a hacker, right? So let's start with an overview of an IoT device. So in the middle, we have the system on the chip, which is basically the processor, and this is very similar. Like if you look at the schematic, at the picture, it's very similar with what you have like as a general purpose computer, your laptop and everything. So we have components like storage. We have components like debug interfaces. We have sensors, for example, cameras, lasers. We have actors like motors. We have connectivity. This can be Wi-Fi, Bluetooth, Zigbee. This can be literally anything. And of course, we have firmwares, but not only one firmware, but we have most of the time multiple firmwares. For example, for the operation system, for the application, even Wi-Fi chipsets have their own firmware. So the problem with this is basically you have all these components, and as a defender, you need to kind of more or less make all of them secure. The problem is, for me as an attacker, I need to find a way in one of them, and I win, which is like a little bit unfair, because basically it makes attacking for me easier than for you defending. And so speaking of which, basically for me, from an attacker perspective, these are the most important ones. So I'm looking for the debug interfaces if I can find them, and I look for storage if I can, extract the firmware from that to kind of find further vulnerabilities. So this is like basically the thing which we want to look at. All right. So most IoT devices are surprisingly, if you have like a smart fridge, if you have a smart washing machine, which are actually existing, they're very similar to what you have in your pocket, which is your phone. Basically the performance of these devices is very, very similar. So imagine technically you could take this vacuum robot, if you would kind of connect a display to it, you can install a web browser, you can do whatever. It's like very, very performant. So let's talk about the features and connectivity of IoT devices. As mentioned before, lots of IoT devices have very powerful hardware. They have multi-core CPUs. Most of the time, surprisingly, they are based on Linux operating systems. So even if you have smartwatches, there might be some kind of Linux or Android running on them. And they're extremely similar to general-purpose computers, which means that they can be abused to do other things too. And IoT devices are also typically connected to other devices or the internet or the internet. So basically, a smart home is not very smart if you don't have any other devices. And most of the products which you can buy for, which are smart, require some kind of internet connectivity. So all this stuff is kind of like it's a problem. It's like you have like a very unknown kind of thing in your home, which is very powerful, and you have zero control over it. To give you some idea what we're talking about performance-wise, I have here two examples. This is like a mainboard from a vacuum robot. It has a quad-core ARM CPU. It has 512 megabyte of RAM, 4 gigabyte of flash, and it runs Ubuntu. So the vacuum robots run Ubuntu, under the hood, basically. Another example is the Amazon smart speaker, which has also like a quad-core ARM CPU, 512 megabyte of RAM, 4 gigabyte of flash, and runs Android. So even like, small components which you would think like, okay, there's no way that it runs like a full operation system, they run a full operation system. So, let's talk about cybersecurity. And I mean, this is a security conference, so, that's an important topic. So, the thing with cybersecurity is, technically, it's a very well-researched and, a field, and we have a lot of experience in that. So since the 90s, we started to implement like security mechanisms. We started to do things like secure boot, firmware signatures, attestations. There's a lot of papers and a lot of research in doing that. The same thing we have for software. So there's a lot of best practices. These secure development life cycles, which are, I think, from Microsoft at some point. There's programming guidelines. There's like lots of books written about how to do things secure, how to write secure software. Well, the problem is, if you talk about IoT, imagine there's the man in black coming and deleting all this knowledge, and all of the stuff is not applying for IoT devices. It's kind of surprising. So security-wise, for many IoT devices, we are back in the 90s, where we don't have, for embedded devices, ASLR, we don't have like the signatures or like secure things, right? So, for passwords nowadays, even if you, read out a file system, you notice, many of the IoT devices using the, password encryption, which is called Descrypt, which was used in the 80s, which kind of shrinks your password to 8 characters and does some weird kind of stuff. We are still using that for IoT devices nowadays, which is kind of like a scary thing. Cybersecurity is really hard, and it requires knowledge, and you being here is a very, very good thing. So you learn about, typical problems. And every year new attacks are developed, and the problem is also not only it can be your fault, but you did something wrong, but a lot of third-party code, which comes from some external sources, SDKs, might be also vulnerable. And IoT devices are very, very complex. So to create an IoT device, you need knowledge about hardware, software, and networks, and it's a lot of challenges for developers. The complex part here is you have a dependence on the internet. And I have an example here. I'm sorry, it's in German. Let me just kind of summarize what is going on here. There's a very, very famous heating appliance manufacturer in Germany, which is in majority of all the German homes. And they had an internet connection, and some people figured out like, oh, hey, there's like a way to basically remotely disable the heating system and crash it and permanently break the heating system of people. And I think this was, thankfully, it was in spring. But imagine people would have mass break like hundreds of thousands like heating systems, before the winter, that would be like a catastrophe. Now the question is, why doesn't the heating system need internet? But, I think I'm the wrong person to ask that question. Let me guide you real quick about through the IoT development cycle, how I typically see it. So IoT vendors and developers are often very lazy. One quick question which I forgot. Who of you is a student? Okay. So imagine the typical IoT developers are like us, you guys, who have an assignment tomorrow at midnight, and you need to quickly develop something. So you have a very limited development time. You need to kind of pull out these assignments or like the products in this particular case very quickly. And, quality control, well, I mean, there's no time and it's kind of expensive. So what typically a lot of vendors are doing, they get the SDK from like the chip vendor, they modify a sample code so that it works for this product barely, If it works, great, publish a firmware, publish a product, we will fix it later. So typically like how typical, assignments of undergrad students, in CS. If it works, if it's janky, it's fine, it will just pass the grade, whatever. The sad part is a lot of IoT vendors are working with the same system, which is a little bit scary if you think of, we have a little bit of more outreach. Another thing which is kind of important is product support and lifespan. So development cycles typically for smart devices like vacuum robots, for cameras, are very similar to smartphones. So you have like new products and new models every year, even though that they technically don't change that much. And the product support for devices dropped after 1 or 2 years. So typically, as soon as the product is developed, the focus of the developers moves to the new product, so they kind of start to develop a new product. The problem here is smart home devices are used longer. So if you have like a washing machine or dryer, then you typically use it between 7 and 13 years. There's no real incentive for a consumer to replace a working device. Like if I have a washing machine, I don't want to buy a new washing machine next year because it has like some cool feature where you can play better music or something. And for a vendor, as soon as you sold the device, there's no incentive to actually support our devices. So this is kind of like the most important part. So the question is like how IoT devices become vulnerable. And one of the main issues, and this is like not only like to Xiaomi, but this is like for all companies basically, security doesn't pay. If you develop a product, your customers don't pay for security. The other problem is customers are not very well educated. If you ever did tech support, you will probably know that. They do stupid things because we want to have it like very easy. So they connect IP cameras directly to the internet without the firewall. They don't change the default passwords, and they're not really aware of the functionality of the device. So they don't know like, hey, this camera, if I connect to the internet, someone else can access that, or if I put the robot like in some kind of weird account, then someone else can do other things. So it's like consumers are very like unaware of powerfulness of their devices. And this behavior, which I discussed before, from developers and consumers leads to vulnerable devices. And as an example here is like the Mirai botnet, where basically hackers abuse the default credentials of like IP cameras to create like a botnet with millions of cameras. So this was like a huge thing. And this was part of the reason also why I kind of started to do this research, because I'm kind of curious, like, okay, how insecure are these devices actually? Did we learn anything from the past? All right, let's go to the next thing. I just want to briefly go over some methods to do hardware reverse engineering. So let's talk about tools. So let's assume you want to start today with hardware reverse engineering. The good thing is actually you don't need that many tools. So surprisingly, a lot of people can do that. Typically what you need is like some kind of UART adapter. If you have like cheap devices, most of the time you find the UART and you can maybe get something. If you have a Raspberry Pi, it's a multi-tool. I will explain later about how. If you have soldering iron, there was a soldering village outside. I think it might be still running. That might be a very useful thing. If you have hot air station, even better. And a multimeter. And that's most of the time all you need to kind of to start. And this was actually the stuff which I started with in 2017 when I was starting all this hardware hacking. I didn't have more than that. A couple things nice to have if you're, a little bit more advanced, like eMMC NAND flash readers. Those are extremely helpful if you, are able to dump the flash or remove the flash. A very flow oven can save your life sometimes, and if you like really, really fancy, you can get a microscope. But there's also very cheap USB microscopes, which might be helpful. As mentioned, the Raspberry Pi can be a very universal tool. I mean, you can use it for JTAG, you can use it to read out SPI flash, which most IP cameras, for example, have, or routers. You can use it for UART, so you don't need a UART adapter necessarily. You can mount flash images. So it's a very cheap way to get into that. So if you think about getting into hardware hacking, don't be afraid. I wouldn't say it's easy, but the entry level is not that high. So what kind of things are we looking for in hardware hacking? Well, we try to find debug interfaces. One of the typical ones which we're looking for is UART, which is like the serial port. It gives you like the serial output of like the firmware. You can interact with the bootloader. This might be something useful. Might be useful to get stuff. I learned today from the Apple HomePod talk that they have UART too, which is interesting. I'm surprised that Apple had that. The other thing which we're looking for sometimes is USB. And this can be, like a USB host or client. Sometimes you can just plug in a USB stick. It will magically execute things which are in a USB stick. or you can use IDB. This typically gives you access to the operation system. You can sometimes interact with the bootloader, so if you get it like in a bootloader mode, and you can download for some devices firmware onto the device, which might need to be signed or not, so it kind of depends. And it can be also like a potential boot source. So I got a lot of devices hacked by basically somehow forcing them to boot from the USB stick, booting from USB. Actually, my recent DEF CON talk is using basically this method to root most of the vacuum robots from Roborock and Dreamy. Another thing, if you want to work especially with embedded devices, which are like Cortex-Ms or something, or like very small ones, you want to look for chip debugging pins, in particular JTAG or SWD. This exists for most integrated, so this is existing for all ICs, basically, which I know in one way or the other, because the vendors need to test that things themselves. Most of the time, what it allows you, if it's not disabled, which it isn't for most cases, except if you look for very, very high-tier companies, it allows you to read registers, memory contents, manipulate instructions. And the reason why it's there is because it's used for the initial firmware provisioning. So the vendor must have it in one way or the other, and they cannot remove it afterwards. At least, it's somewhere on the PCB at least, except if they disable it. So why is it useful for us? Well, we can potentially learn the memory layout of something. We might be able to dump the firmware, and we might be also able to extract firmware keys or like secret keys from the memory. A thing which probably most of you in the beginning won't be like really want to do is like the flash memory chip-off method, or ISP. And it's an example from Amazon Echo, where basically if you use a hot air gun, you can remove the flash chip, use like a external reader, dump it, and potentially put it back, or like find the pins. On the right side, you see the ISP method. If you figured out how the traces are going on a PCB, you can just use needles to kind of connect to the traces and don't need to use any soldering to kind of, read out data or manipulate data. So this is what I used for, getting a paper with Amazon Echos. A lot of people are very, very worried about warranty seals. In the sense of like, oh, what happens if the device breaks on its own? But in a lot of cases, there's ways around that. I have here an example from a Xiaomi router, where on the left you see a picture where the UART pins are located. And one thing which I figured out is you can use like paper clips to go through the case without breaking any warranty seals, and just poking them into the holes and just have UART without touching any of the warranty seals. Very similar method I used for the Roborock vacuum robots. This was the DEF CON talk which I was holding 2 weeks ago. Basically, one thing which I noticed is that you can access all the data pins of the flash memory from outside if you just remove like one small cover and one rubber thing. So you could just scratch off like a little bit of a trace, put in a needle, and then you get root access at the end of the day. So bypass all their security mechanisms, and not touching any warranty seal. So from outside it's not visible if you look at the device, that the device was ever manipulated, which is a kind of a problem for people. You could basically give manipulated device which are kind of backdoors to people and, spy on them. But that's a different topic. Don't do that, by the way. It's probably illegal. I hope it's illegal, at least in India. All right. Okay. So let's finally talk about the Xiaomi ecosystem. So Xiaomi is basically mostly known for their smartphones. If you participated in a live hacking event here, the Poco phones are from Xiaomi. They claim to be the biggest IoT ecosystem worldwide. So they have like 6 different regions. So there's a global thing which is having its service in Singapore. There's the EU service in Germany. There's the US service. There's a Russian domain, Russian region. There's an Indian region, and there's the mainland China region. Like in March 2023, last quarter, they basically claimed that they had 618 million IoT devices like online in their network. The thing with the Xiaomi ecosystem is kind of interesting. Basically, not all of the devices are actually from Xiaomi. So what happens is the ecosystem consists of many, many different vendors, which basically go to Xiaomi and are like in the ecosystem, and it forms like one ecosystem, but it consists of many, many different vendors. The ecosystem itself is called Magi, or AIoT, because they started to do AI, and so it sounds nice. The good thing for us as attackers is the communication protocol to the cloud is the same for all of the devices. No matter which company you have, the protocol is more or less very similar. And the other cool thing is it supports a lot of different technologies like Bluetooth, Wi-Fi. It can also do PLC nowadays. So it's very, very cool ecosystem from perspective of manufacturer of hardware. And that's the reason why a lot of manufacturers of hardware go to Xiaomi and basically are part of the ecosystem. The thing is here that the implementation of the actual device, of the actual functionality of the device, differs from vendor to vendor. Because it's their responsibility to implement somehow the cloud, connection, but the whole software, the logic of the device is like up to the vendors. And here lies the problem. The software quality between the vendors is very, very different. There's some which have like nowadays more experience of security by getting hacked by me, and there's some which are kind of new, which never experienced any security issues and basically are open. If you buy the device today from them, you can probably root it in 5 minutes. And a lot of custom features are basically added in that firmware, which is kind of like the interesting thing for us potentially to, abuse that. So the products in this ecosystem can be literally everything. What I mentioned before, we have fridges, washing machines. I think we have smart beds, and for whatever reason you need that. We have lamps, cameras. There's the scooters. So Segway is kind of belonging to one company, which is like in the Xiaomi ecosystem. Vacuum robots, which are my specialty. So we have a lot of things, right? I, of course, had a lot of contact with the Xiaomi security team, which is responsible for the security of the software, the cloud, and the physical stores. So if you have physical stores around here, then they're kind of responsible for them. They have access to the source code of Xiaomi developed products, which are a few, like the Poco phones and some other things. But they don't have access to the source code of third-party vendors. So they have no idea what's inside of the Dreamy or Roborock robots, because we cannot access it. We can only see the firmware binary blob. Their focus is primarily on smartphones and the backend, but they kind of look a little bit on IoT, but at least from last I heard, that's their main focus and their main business model. They have a bug bounty program for HackerOne, so you can apply there and start hacking. They pay up to $30,000 per vulnerability, so it's fairly nice. From my experience, they react very quick and they fix things if they can fix it. And they work on improving guidelines for OEM. So they have a kind of like catalog of like things, of requirements, which we kind of expect from vendors, but it's kind of up to the vendor if they implement them or not. I mean, they kind of need to sign that they did it, but realistically, who knows? All right, so let's start to actually reverse engineer the ecosystem. One of the things which is kind of important if you start to kind of reverse engineer things and which are related to the cloud, you need to kind of stay undetected. A lot of companies have some kind of intrusion detection systems, or like some systems which kind of block your account or like do some other stuff with you if they kind of notice that you do sketchy things which are not done by your normal app or a normal device. And so what I do is like I have a stack of phones. I have more of them like that, which have different Xiaomi accounts, which are connected to different server locations, and which are spoofing GPS coordinates, so that they hopefully don't know that all of them are in the same place. And I use different Wi-Fi networks to kind of separate all the devices. With VPNs to Hong Kong and China, sometimes I need to download a couple of things, or sometimes I use Tor, but nowadays I think they kind of catch on that and kind of crack down on Tor usage. The importance is if you ever do that, make sure that you never mix devices between different accounts. Some people, add it to account A and then move it to account B and then think like, oh, okay, it's like kind of safe, and then start to add more things to account A. But the problem is like if there's any connection in the past with like the devices have been connected to both accounts, that's kind of like you can get caught with that. So be a little bit more careful. All right, let's talk about the communication relations of a typical, Xiaomi IoT device. So the central component is the Mi Home app, which is on your phone, which you use for provisioning. It talks with over HTTPS with the Xiaomi cloud. It talks with your device over Wi-Fi. It talks to your smaller devices over Bluetooth LE. You use it also initially to provision the devices to connect to the cloud. So all the Wi-Fi capable devices have a direct path to the cloud, which is not going through the phone. There are some special devices which are like Zigbee devices. They talk through a gateway, which are also like directly connected to the cloud. So there's a lot of things which are, obviously don't need your phone. For example, if you're not at home, the device should be still able to function, right? So there's like a direct path between this. The question is like, if you have this kind of communication relations, what would we use to kind of, analyze that? And there's basically two methods. One method is, well, we take a look at the app. So we can download the app for free, as an APK. It requires some kind of cloud interaction, so you need to kind of check your local laws if you, can do probing against the cloud. You can get a lot of information for a lot of models. Whatever the app supports, you can, potentially get something. If you reverse engineer the app, you can get some information about potential vulnerabilities of the cloud API. One of the problems is kind of like that the vulnerabilities can be fixed very quickly because you're basically talking to the cloud, right? So it's kind of like a problem. And on the other side, this is what I prefer. You analyze the device itself, so you need to get the device, obviously, so you need to spend money. You can do any attack you want. I mean, the vendor won't figure it out if you don't talk to the cloud. The problem is kind of the information which you get from that is very specific to the kind of device which you have, like the device model. And you find vulnerabilities on the device itself, so it doesn't necessarily give you information about the cloud, but sometimes it does. So I have examples of that here. The vulnerabilities can be fixed by the firmware updates from the vendor, but most of the time it requires some kind of user interaction, right? So potentially you can prevent getting firmware updates on your device by blocking them. And as mentioned, as a hardware hacker, obviously this is my most favorite method. But let's talk about the app method for a second. So what happens if we reverse engineer the Xiaomi app? So the idea is, well, we want to understand the interaction between the app and the phone and the app and the cloud. And the advantage here is we basically will be able to see all the information which the app can see, because the app needs to kind of, interact with this information. In one of the typical ways how you do that is you need to, get the APK. You can disassemble it with GADX, which is, I think, the go-to kind of tool for disassembling APKs. I'm not sure if there's something newer. You can modify it, so you can repack basically with APK tool. Xiaomi apps are surprisingly chatty. So if you connect to Logcat, you will see like a lot of information which you shouldn't usually be able to see, but they are extremely chatty there. And if you have an older phone and you have the exposed framework, then you can also modify some flows. So it's a very, very cool fun thing. What did I figure out about the Xiaomi app? Well, they kind of knew that people might disassemble the Xiaomi app, so they started to partially obfuscate that and use like native libraries. So it means they're written in C. The device-specific functions are basically outsourced to plugins. So the Xiaomi basically gives you only like the framework, but the actual functionality logic is like different plugins which are developed by the manufacturers. The communication to the cloud is authenticated with OAuth, with a very weird kind of thing. So there might be something broken in there. They use a layered encryption because they then trust their scheme. So they have outside HTTPS. Inside they use some AES with session key, and I think nowadays they do even another layer of encryption inside. And the message format is very, very nice because it's JSON RPC. And I have here like a structure, example of a structure. So you have the actual core app, which is delivered by Xiaomi. It has some functionality like just adding a device, listing other devices, send device updates, and manage the plugins and also the permission. But the specific functionality for devices like developed by, in this particular example, Roborock or like Lumi for like the camera. And so the vendor basically decides what kind of functionality the device has and the plugin has. And this is like an important thing for you, because the vendor might be really, really bad in implementing that, and this might be very helpful for you. I have here an example for like an intercepted API call, which was kind of interesting and eye-opening for me. So if you list the devices, then you get like a list of like all the devices with the IP addresses which we have currently, MAC addresses, serial numbers, and so on. One thing which I noticed is that the cloud kind of knew where the device is exactly. And I was looking at this thing and I was like, this longitude, latitude is very, very familiar. And then I kind of noticed like, wait a sec, that's my lab. The question is like, how does the device know where it is? And the thing is, the phone is snitching on you, because the phone knows where it is and the phone has direct contact with the IoT device, so it assumes like, okay, it's there. Interestingly, they disabled that for all the regions, for all the other regions except for mainland China, after it was kind of published a couple of years ago. So that's not the case anymore, except for if you have a Chinese account. The way how the app handles permissions is kind of interesting. So there's like a couple flags which are kind of set for per device. In this particular case, you are the owner of the device, so admin flag is one. share flag is 0, so the device is not shared, and the privilege level is 16, so you have like more or less the privileges from 1 to 16. So you can do literally everything with this device. You can update it, you can set settings, you can share it, etc. In this particular example, the admin flag is 0, the share flag is 1, the permit level is 4. So you're not the owner of the device is shared with you, and you can do less things. Let's talk about the problem. Well, the cloud server is actually not aware what kind of commands you can send to the device via RPC. So we don't have like a whitelist, we don't have a blacklist. The plugin, because it's like implemented by the vendor, can do whatever it wants. So it can send any arbitrary commands to the device. And from my understanding, the commands are actually not filtered, and the cloud doesn't know what your privileges are, because they're enforced by the client application, which is not the best way. By the way, if you ever develop an application, never let the client application decide what kind of privileges it should have on the server. There were some attack vectors which were kind of obvious, so you were able to push firmware updates to any device, any of your devices, no matter if it's shared or if it's not shared. And another thing is, if you know the RPC endpoints, you can basically send any garbage to the device, and it will be forwarded to the firmware. And in many devices, it kind of does things like command injection potentially. So this was very, very, very bad for them. So as soon as I saw that, I was like, hey, what about if I create like a fake Mi Home app, which is basically emulate the Mi Home app, implements all their key generation and login process, and is not distinguishable really from like a real app. And then I can use it to retrieve device information and send arbitrary commands to my devices, including firmware updates or downgrades. So I could now downgrade my firmware, my devices, and do like automated collection of firmware versions and models. And basically, in combination with emulated devices, I was able to, do a lot of things. So this is like basically what I do right now, which is kind of, fun. All right, let's talk about real quick about the device approach. So in this particular case, we want to understand what the device is actually doing. And the advantage here is that we get the data directly from the device. We don't need to care about transport encryption if you have access on the device. And the typical method here is like you need to kind of disassemble the device at some point. You need to access the bug pins, and you potentially want to get the firmware somehow, either from the flash or if you have a shell access from the device itself. The problem is some of the devices are very tricky to get to. In particular, I have an example from a light bulb, which you sadly need to use a Dremel to cut it open. And obviously you shouldn't use the light bulb afterwards after you get the firmware because it's broken. But sometimes you need to sacrifice devices. I think this is one of the 5 to 10 devices out of my 700 IoT devices which I had to sacrifice for to get the firmware, which were not usable afterwards. All right, let's talk about the interesting part. Let's talk about the findings. So what was I able to find in a recent time with both methods? Well, there was this one thing, which is the IP camera plugin fail. And I mentioned before that the plugins are developed by third-party vendors, whoever is developing the product. And what happened here is they developed an iPhone plugin, which was buggy, and it was crashing very, very often. The plugin itself had like a hard-coded S3 bucket where it was basically uploading the crash dumps every time it was crashing. This wouldn't be a necessary problem. The problem was here that they uploaded the user account tokens for the XIAOMI users to that S3 bucket, and everyone could basically access that. And if you had this token, it's like a cookie basically. You could access to the user account of the user. And you could access all the IP cameras. You could interact with all the devices. And there were thousands of devices which were basically crashing and were uploading their credentials basically to that thing. The problem is if you change your password, this doesn't invalidate the service token. So basically you were able to stay in that thing for, I think, 3 months. And there was no mechanism to kind of invalidate that. So this was kind of bad. But they fixed it, I think. All right. The other thing which we did is we had to, I think at some point we had a special API for iPhones, in mainland China in particular. And they didn't do a check if whatever device you send commands to is actually yours. So you were able to, send OTA updates to random devices. Which is a problem if you are able to send malicious firmwares which are not signed for some devices to everyone. The problem also was that device IDs are typically like a 10-digit number, which is incremental. So yeah, that's a problem. They fixed that very quickly, so it doesn't work anymore. So if you try today, good news or bad news, it doesn't work. Another thing which is kind of interesting is the camera access on rooted devices. You saw a quick demonstration before I started my talk. Most of the vacuum robots which have cameras use some kind of like video for Linux subsystem, so you can access the cameras from inside the operation system. Some vendors were very, very nice and even left some tools for us, so which we could use to access the cameras. One thing which I found, many companies store the pictures on the flash memory. Very little of them delete them after a factory reset, so if you buy a used device, you might still have all the pictures. And a lot of them obviously upload them to the cloud. Okay. So, another thing, which is kind of interesting, one particular company, Dreamy, was very nice to give us the bug interfaces. So at some point I was reverse engineering the devices and I was able to get root access on the device through U-boot. And this was the first time Dreamy devices were rooted. One thing which I found there is the method to compute all the root passwords for any device. So it's basically derived from the serial number. We were able to find interesting things there. For example, we had a reverse SSH shell to one of the development servers, and the username and password was hard-coded in the firmware of the robot. And what you could do is, like, you could basically SSH to the development backend, and the user, for the credentials you had root, you could do with that, so you were root basically on the servers. We used the server for development, but the server had also access to a lot of S3 buckets. Which kind of shows you, if you do physical attacks on the IoT device, you might exploit the cloud at the end of the day. The same company had also some interesting debug scripts which are executed from time to time on some devices, and it was downloading some scripts from the NAS of the developer, from his personal NAS, which was in China, in Shanghai. And he put the admin credentials for his personal NAS with his personal pictures and some other stuff in the firmware of the device. So again, interesting. To give you some idea what camera access, by the way, looks at from vacuum robots, this is a Roborock model. This is a G10S, by the way. This is like how it looks if you have camera access. Dreamy puts a little bit nicer cameras in their robots. So this is a example from Dreamy photographing itself. And on the right, you see what typically gets uploaded to the cloud. Another thing from Dreamy, because it's kind of recently, they kind of also messed up their firmware signatures. If you combine multiple things together, you might figure out that it's a huge problem. Basically, a lot of new generations of of Dreamy robots encrypt and then sign their firmware. But the way how we do that is very, very interesting. The outside of the firmware is encrypted with a static password, which is more or less the same for all of them. Then we create a random file, which is used as a key for the inside archive. And instead of signing the actual firmware, we sign the key. So the key is signed, but not the actual firmware. So you can recycle the same key to sign, just create your own firmware. And with that, we were able to just create like fake firmwares, which were correctly signed from basically from the robot. And if you push it on the robot, then basically you can do whatever you want. And there was way more. So, I mean, I had access to routers, vacuum robots, obviously, cameras. I got at some point a washing machine. I got root access to the washing machine. There's not that much we can do with a washing machine because it doesn't drive around, but, it was like a interesting thing. And there was way more credentials to random servers from random companies. I didn't find so far any IoT company in the XIAOMI ecosystem which didn't have at least some kind of, broken things. But just to kind of clarify, it's not only XIAOMI which is doing these errors. I mean, they kind of crack down on them, but all of the IoT companies have some kind of things, even Amazon. So don't feel safe like, oh, I'm not using XIAOMI. Amazon does the same thing. Google is cracking down on that very, very hard, but generally all of the companies make the mistakes. All right, let's talk about a summary. What did I get with all of that? So some of my bugs I submitted to HackerOne. Primarily these were things which were remotely exploitable, which is a problem. Or we were cloud credentials, like the S3 thing which I mentioned before, or where user data was at risk. So where basically people could crack or attack multiple users at the same time. But I rarely submit bugs to actually the vendor in advance of talks. So the thing is, My main goal is like to get root access on devices, and that kind of means that I don't want the vendor to know that they are vulnerable to particular things, so I don't tell them. What I do instead is I go to talks. So basically, my initial research started in 2017 with Xiaomi devices, and then through all the routing exploits which I got, I basically was going to any conference I could with new things. It's not so that I recycled the same talk all over again, but every half year I found completely new things, which was completely new method to get into device to exploit things, and basically the way how the Xiaomi cloud develops, the huge technological advantages like Reiki robots. I was advancing with them, with the vulnerabilities every time, and this is kind of great. So you at some point you need to choose, like, okay, do I submit a talk like for a small bounty or no bounty at all, like for fame from the company, or can I go like to cool events like Nullcon, for example, as mentioned here, and present my research to an audience and get invited to talk to interesting people. So I feel this is like one of the things which you need to decide at some point. Right. As a summary, hacking IoT is fun. There's a lot of IoT devices. So I had a discussion, I think, today with John, I think. There's a lot of, there's so many IoT companies. I think there's more IoT companies than people in this room. So you should definitely take a look at this field. Unknown companies might be super easy to hack. So if you just start out, just go to AliExpress, just buy the cheapest stuff which you can buy for money and take a look at that. The entry in the field might be easy, so there might be some basic tools which you get. Finding IoT vulnerabilities can be rewarding. You can get potentially lots of dollars if you submit bug bounties, or you get a lot of fame if you don't and submit just talks. All right, some final notes. Don't use your knowledge for bad things. You might, like I mentioned before, you might get at some point access to some user data. Don't do, bad things with that, please. Be especially careful if you interact with the cloud infrastructure. You might break things or, law enforcement might come after you. Check your local laws. I sometimes travel between Europe and America to kind of avoid particular legal things, because some things you can do legally in Europe, but not in America and vice versa. So there might be some things. And if you're interested in IoT hacking, I will be around at Hardware I/O and I will bring my lab. So feel free to join me there. And now I think I have maybe a couple minutes for questions. Otherwise, just see me afterwards. Thank you very much.